Major disasters such as earthquakes and tsunamis strike unexpectedly. There are great expectations for tough robots at such times to work in extreme environments, such as sites affected by disasters, to assist in activities that protect the lives and property of citizens. Robots provide assistance to rescue parties to minimize the damage from disasters. The ImPACT Tough Robotics Challenge aims to accelerate innovation in tough robot technologies. Researchers from institutes and companies working for the ImPACT Tough Robotics Challenge gathered here at Albayama campus of Tohoku University to hold a field evaluation session. In the field evaluation session, demonstrations of the latest research results in responding to emergency situations, such as major earthquakes, were held at simulated emergency sites. The simulated response to the disaster was as follows. A major earthquake has resulted in the collapse of numerous houses and landslides. It is assumed that there are survivors who need to be rescued in districts that suffered major damage, but the details are unknown. A disaster countermeasure headquarters has been established on site. In mountainous areas that cannot be accessed by manned helicopters, the Disaster Countermeasure Headquarters needs aerial images to understand the overall situation of the disaster and plan the response. They then request the deployment of aerial robots. The aerial robots are notable in their robustness in flying safely, even in strong winds or torrential rain. And they can fly beyond visual range in formation, according to a flight path programmed on site. Their flight can be monitored through satellite communication. The numerous photos taken by the aerial robots are pieced together to create a 2D ortho image to cover the entire flight area, while laser sensors are used to create a 3D topographical map to provide the Disaster Countermeasures Headquarters with the information needed to make decisions. This aerial robot is equipped with a robot arm, and its key feature is its ability to maintain the position of its center of gravity regardless of its arm's position, making it useful for holding and transporting emergency supplies. Roads are often blocked in major disasters due to landslides and collapsed houses. Construction robots play a vital role in removing rubble from places that are too dangerous for people to work in. With a double-swing, dual-arm mechanism, this construction robot is capable of carrying out delicate work with its two arms, which are operated by a high-output, low-friction hydraulic system. The robot is also characterized by its ability to handle heavy loads. To make it easier for the operator to understand the on-site conditions while controlling the robot remotely, the sense of both force and touch are fed back to allow the work to be carried out efficiently. Using hydraulic pressure and vibration sensors to estimate these states does away with the need to install sensors on the tips of the hands, boosting the reliability of the robot under harsh environmental conditions. Using a wired power-feeding drone flying overhead and images captured on multiple cameras installed on the robot allow monitoring the progress of work and surrounding conditions from any viewpoint. The obstacles have successfully been removed by the construction robot. Information was received that a survivor has been trapped in a collapsed building. A cyber rescue canine starts searching for survivors. The dog wears a cyber rescue suit equipped with a camera, a microphone, an inertial sensor, a GPS, and an electrocardiograph. It has 4 main functions. First, transmitting images and audio in real time. Second, displaying and recording the location of the rescue dog on an on-site map. Third, automatically identifying the personal effects of victims in images recorded by the camera. And fourth, estimating the enthusiasm of the dog from fluctuations in its heartbeat and acceleration. These functions enable remote monitoring of the dog, greatly enhancing the efficiency of search operations. Thanks to the cyber rescue canine, the location of a survivor trapped in the rubble has been identified with high probability. A thin serpentine robot called the active scope camera is used to investigate the situation of the survivor and the condition of the debris within the cramped spaces under the rubble. The active scope camera moves forward by vibrating the cilia which cover its entire body, and it is controlled remotely by transmitting its senses of vision, hearing, and touch. It also has a new function for levitating its head by air jet, greatly enhancing its mobility and allowing it to easily take an extensive view of its surroundings under the rubble. In addition to this automatic insertion apparatus, the system is able to estimate the location of the active scope camera in the rubble by using its numerous inertial sensors, the travel time of sounds it emits itself, and image data. Based on a map of the rubble created by the active scope camera, rescuers ascertain the state of the rubble in the collapsed building to make rescue plans. The microphones installed on the active scope camera pick up all kinds of background noises. It is difficult to pick out the voice of the survivor. This has led to the development of technology for removing extraneous noise and enhancing the sound of human voices. So, take a listen. The voice of a survivor trapped under the rubble has been confirmed. A survivor has been discovered. Thanks to information obtained from robots assisting in the search operations, a survivor was safely rescued. Infrastructure and industrial facilities are damaged greatly in major disasters. To prevent and simultaneously minimize the damage from disasters, it is important for facilities to be inspected. High places and narrow spaces pose a constant danger to workers. Gas leaks, heat, and radiation also pose risks inside plants. This thick serpentine robot is carrying out inspections of plant piping. It is capable of moving in narrow, tight places. Until now, it was difficult to pass pipe support such as this, but the robot now has the capability to do so. Moreover, through research on its movement, it is now able to move up and down vertical ladders without tangling its cable. The remote repairing of industrial facilities requires robots capable of moving on steps, bumps, and even over rubble to carry out heavy-duty jobs. This four-legged robot is capable of bipedal locomotion in tight spaces. While on uneven terrain, it can even crawl on the ground for greater stability, allowing it to move and work in a variety of environments. Here it is using one of its limbs as an arm to open a valve that had been shut so tight that it was not easy for a person to turn. This field evaluation session, based on a simulated response to a disaster, has demonstrated how robot technologies can help in emergency responses and accident prevention in the future. Questionnaire surveys have revealed that many session participants expect robots to become indispensable tools for the safety and security of humanity. ImPACT.